Welcome to lesson number 7. We're going to be looking at the ambiguous case of the sine law. Now, I'm starting on page 202 with class example number 1 for this video, but we are actually going to be looking at the warm-up as well as the investigations for this in class with your groups. So, with the ambiguous case, just a kind of a background of why it's called the ambiguous case of the sine law. So in this first example in the warm-up, students were asked to determine the measure of the angle ACB, so this angle up here, in which AB is 6 centimeters, AC is 4 centimeters, and angle B is 30 degrees. And so with this information, Scott constructed this triangle and Brittany constructed this triangle. Now both of these triangles, although different, fulfill the requirements of the triangle given. And so if we look at if we look at side AB, AB is 6 centimeters, side AC is 4 centimeters, and angle ABC is 30 degrees. If we look at Brittany's triangle, AC is 4 centimeters, side AB is 6 centimeters, and angle B is 30 degrees. So same information, different triangles. Therefore, the measurement of C is going to be ambiguous as to which case we're actually looking at, because with the information given, it can actually be both. Now, this occurs some of the time, and there's some criteria as to how many sides or how many solutions there are going to be for a triangle, and we're going to be looking at that in class. However, I am going to show how to do these first two examples. So if I, without using the sine law, determine in which of the following cases there is exactly one solution to the problem and there's only one triangle which can be constructed from the given information. So if I calculate angle C in ABC, where angle B is 56 degrees, side C is 10 centimeters, and side B is 12 centimeters. Now, we know that we could use the sine law in order to determine angle C. However, they don't want us to use the sine law. What they want to know is how many solutions there are. So we're not actually looking for the measurement of the angle, we're just looking for how many solutions there are. Now, the criteria here is if my side opposite my given angle, so my given angle is angle B, is 56 degrees, and the side opposite is 12 centimeters. If this is greater than the side that is opposite of my required angle, so angle C, then that means there's only going to be one solution to this problem. And as we do the investigation in class, you'll understand what I'm talking about there. So on Friday, you'll see what that's all about. So again, if the side opposite of the given angle is greater than the side opposite of the required angle, then that means there is exactly one solution. Now in class example B, calculate PQR in triangle PQR, where angle P is equal to 41 degrees, RQ is equal to 3 centimeters, and PR is equal to 4.2 centimeters. Now this is an opposite case. So in this case, my side opposite of the given angle is less than the side opposite of the required angle. So in this case, there's not exactly one solution. There could be more than one. Now, how do we know? Well, if I were to draw this triangle triangle PQR. QPR is 41 degrees. RQ. So this is the side opposite of this this angle, and this is the side opposite of PQR. That's 4.2. So since my angle opposite of the longer side, and this longer side is greater than the side that's given with the given angle, then that means there's only going to be, or sorry, there's not going to exactly be one solution. There could be multiple solutions. Now, again, this will make more sense once you watch the video. Now, classic example number 2, find all possible measures of angle C in the following triangles. So triangle ABC, where angle A is equal to 50 degrees, A is equal to 7.5 centimeters, and C is equal to 9.5 centimeters. So we're looking for angle C. And now we can use the sine law. So sine, if I'm looking for an angle C, I want to have sine C on top. So sine C is equal to sine A over A. And I'm going to move over here. So sine C over 9.5 is equal to sine 50 over 7.5. Rearrange for sine C is equal to 9.5 times sine 50, and that divided by 7.5. And we get an answer of 0.9703. Now, if we, with that, remember we need to come up with our angle. And so 0.9703 results in 76 degrees. Now this 76 degrees is a reference angle, okay? So I took the inverse of this, of 0.9703, and I get 76 degrees. So that's my reference angle. Now, if I look at the criteria here, so I have my given side, and my side opposite of C, or sorry, my side opposite of my required angle, which is C, is larger than the side opposite of my given angle, which means that there's not exactly one solution here. Now, in order to find out the other solution, so one of my solutions is going to be 76 degrees. So my angle C is going to be equal to 76 degrees. But it's also going to be equal to 180 minus 76 degrees, which is my obtuse angle, which would be 104 degrees. So my angle C is equal to 76 degrees or 104 degrees. Again, right now, this probably seems confusing if you haven't done the investigation. And so definitely do the investigation first and then perhaps even come back to this video. Next, we're doing the same thing. Sine C is, or sorry, angle C is what we're looking for. So we're going to set up our triangle the same way. Sine C is equal to angle A here. So sine A over A. And so sine C is equal to sine of 50 degrees over 9.5. And so things are a little bit, now it's opposite, right? So all we've done is we kind of rotated the angles around our triangle, or the sides, not the angles, and just the length of the sides. So again, sine C now is going to be equal to 7.5 times sine 50 divided by 9.5. This results in 0.6047. And if I take the inverse of this, I get 37 degrees. Now, remember, this is the opposite case of this one here, where I have my given angle of 50 degrees, and my side opposite of my given angle, which is A, is 9.5 centimeters. But my required angle, which is C, the side opposite of that is less than the side opposite. So that means that there's only one solution, and that's equal to my reference angle. All right, so that 37 again is my reference angle, and this also happens to be the length of the side there.